Hello again. Today we'll be discussing how to use variables in C#. We'll talk about what they are, how to declare them, and what data types, and how to convert values from one data type into another, etc. We'll also look at the difference between statements and expressions. Let's look at the building blocks of code. These are variables. Now if you think back to your algebra class, you may have been given a problem to solve such as x equals 3 and y equals x add 7. So what does y equal? X and y are the two variables here. As x is equal to the value 3, we see that y would equal 10. So basically, these variables represent a value. So a variable can be regarded as a space that is allocated to the computer's memory to store some value, and programmers can reference the value by using the name of the variable. In programming, variables can include anything from strings and dates and big and small numbers and lots more. So we need to declare the variable and how much information we'll be storing so that the computer knows how much space it will take in its memory. We'll create a new project so we can put some sample code, and we'll call this project Lesson 04. And click OK. Then put a single button on the form and then double-click it to get to the code view. To define a variable, you need to say what the data type you'll use. In this case, it'll be a string. Then give the variable a name, any name, but it mustn't be the same as another variable or anything else within the .NET framework. So we can call it myStringVariable. Another version of a variable is called the initialize variable, where you're taking just 2 steps in one line of code. So here we'll begin the same, but we can assign a value to it already. Here I've assigned it to an empty string, but it's possible for us to assign it to any string that we put here by default. In this second line of code, we're saying what size we want the bucket to be by saying it should be a string, then putting a value in it. Next we'll add a few more lines of code. Now we created 2 variables in the first 2 lines of code, and each type is a string. Strings can contain both numbers and letters as well as other combination of keys. Now if we need variables for any kind of calculation, then we'd need to use different numeric data types. These could be either the integer, the double, or a special case called Boolean. Okay, so the first numeric data type which we used was an integer. With this we can store values in variables between -2 billion and a +2 billion. Following this, we use the data type double. This allows you to create quite large negative numbers to quite large positive numbers, as well as insert up to 15 digits after the decimal point. The difference between the integer and the double is that the integer allows you to keep whole numbers and is more commonly used within your properties and settings. The double lets you store data that also has decimal places. The Boolean allows you to keep values which are either true or false. We tend to use those in expressions, which we'll discuss later. As you're just beginning, these are the 4 main data types which you need to focus on and which will help you go a long way. But there are lots of other data types which are available. Now C# is actually a case-sensitive language, So we may type two words exactly the same, but if one has a capital letter and the other doesn't, it would make them two completely different variables. So just be aware of what and how you are typing when using variables. Sometimes the code view will try to help you out by making any corrections to capital letters, but sometimes when you're doing it on your own, these mistakes can get overlooked. Now we'll talk about strings. If you remember, in the Hello World application, we put speech marks around the words Hello World. The reason we did this is because it helps the C# compiler distinguish between a string literal and a variable name. So what is a string literal? It is a fixed set of numbers and letters which are arranged together and need to be displayed. So basically, the variable is the bucket and the string literal is what can go into the bucket. A string literal can be various things, like a message that we want to display to the user, or it can be values which we may want to save to a file or a database. It might contain the file location that we want to save it to, or it could be other text that is important to our application. So we'll look at an example to show the distinction between string literal and variable name. We'll start by creating a variable called hello and make our variable equal to literal string hello. So we'll make some comments on our lines of code, and we'll use my multi-line comment. Then we'll run the application. So basically two message boxes should appear both with the word hello. So the difference between the two message boxes is that the first message box uses a variable and checks in the computer's memory to see what is in the hello bucket. In there it finds the word hello, whilst the second message box shows a string literal called hello. If we now change the first hello to store the value hello world, something completely different. So that's the difference between the string literal and the name of a variable, which is the hello in the first message box. Now the reason we use variables is so we can save values and put them aside until we need to use them. There are many reasons for using them, such as for reference or comparison or for evaluation. So let me show you a little example. Go to your designer and add two text boxes to your form. Then declare two variables. Then add a label. Now let's try it. So when I clicked the button event, it took the value from the first text box and the second text box and linked them together along with a blank space. This allowed me to both words. So what it shows is that we can store values from our text boxes and then refer to them later on, then we can display them back to the end user. So to reiterate, when you declare a variable, you're making a space in the computer's memory in order for it to hold the value of a certain type of data. Now if you try to put in a value of that variable that's the wrong data type, what would happen? Let's try it and see. When you try to run the application, you'll note it'll say, would you like to continue and run from the last successful build? We'll click no because we want to run from our current codebase. So an error list appears and gives us a description of the problems within our code. So in this case, it's found one error and it says it cannot implicitly convert type string to integer. Basically, it couldn't convert the word into a number. Now we can try it the other way around. String equals 3. But again, we get an error saying cannot implicitly convert type int. Now, let's go back to making this an integer and create a double and try this. We didn't ask it to show us any output, but there weren't any problems when we ran the application. Now let's change this around and put 3.14 into our integer. Basically, sometimes the value will be implicitly converted to the correct data type, meaning that the C# compiler will do the conversion itself. This happened in the case where we entered int my value equals 3 double my other value and then set my other value equal to integer. As it was possible for number 3 to be easily converted implicitly into a double value, C# could do it for us. However, C# couldn't do this where we have a double and trying to put that 3.4 into an integer. Another example is as follows. We'll use text boxes on our form. So when we run this example, we can see there are many problems. The first couple have a problem implicitly converting string, which is what is stored within a text property of a text box, into an integer. This was, we said, was the variable first text box. This is also in the case of the second line of code. The last line of code, underlined with a blue squiggly line, tells that we can't implicitly convert an integer, which is the data type of our variable result, into a string, which is what we would want to put into label control's text property. In order to fix this problem, we need to do some data conversion. I've now done explicit conversion. This means that you have to write the code to perform the data conversion yourself. C# compiler will not do it for you, neither will it let you compile and run the application until you write the code. So, if you want to convert a string value into a numeric value, there are a few ways of doing so. One is you just enclose the string variable or string literal with int.parse, then parenthesis around it. That will take the string and parse it and try to make it into an integer value, explicitly performing the conversion that you asked it to do. If the conversion cannot take place due to maybe like nice has been typed in the text box, then you'll have a runtime exception. We'll discuss that later. Another way is the bottom one, the result.toString will take a numeric value such as an integer, double or a boolean and try to convert that value into a string. This way should work because the string isn't fussy about what values can be inside it. Now let's run the application and we'll use it as a basic calculator. So add 3 plus 6 and it will display the value 9 in the label. We'll discuss the reasons behind why I use the .parse and .toString method in a later class. Just remember that you'll basically need to use one of these methods in order to perform a conversion. So now we'll break the application to see what happens. And we get a problem. Visual C# 2005 Express Edition then tries to explain exactly what the problem is. So it says, the input string wasn't in the correct format. It expected to find value in the text box that can be easily converted into an integer value. Because we use int.parse, we would expect to see that value in there before we assigned it into our integer data type variable called first text box. So there are numerous things we can do. Look at the troubleshooting tips or the detail of the problem. We could also copy the exception detail to the clipboard and post it on a forum, etc. So anyway, now we'll stop this application. This is a simple application, and if we want to do a data conversion of the contents in the text box into a more restrictive data type that only accepts numeric values, then we need to do more thorough checking and validation. So now we'll look at some terminology which will be useful in the next tutorial. So first we'll comment on this code. We'll run the application, but there's a problem trying to compile the application. The error list says only an assignment call increment decrement and new object expression can be used as a statement. So why does this error show whenever we try to compile the application? Now it's because x plus 3 is not a statement. It's just part of what C# needs to run this line of code. So a valid statement could be some sort of assignment like x equals 3, or a call like messagebox.show hello world. It could be an increment or decrement of the variable like x plus plus or minus minus x, or it can be a new object expression. So here we didn't assign x plus 3 to anything, we just tried to use it. We didn't make a call to anything or increment or decrement anything the way C# would intend for us to do it. So generally, expressions could be evaluated. We can evaluate this expression and find out what the value would be, but it's not a statement. So what does it mean when we say an expression can be evaluated? Basically, we're evaluating, but we don't write down the answer. So we can use the previous one as an example. Label1.text equals first text box plus space plus second text box. Before we can change label1.text to nice space work, the C# compiler had to take the value from the first box, add a space, then add it to the value in the second text box value. In this case, it was the word work, and it could only be assigned to the text property of our label once the evaluation happened. So the whole line would be a statement because we did the evaluation, then took it and assigned it to the property. So in further lessons, we'll generally be doing another type of evaluation. We'll be seeing if an expression evaluates to be true or false. So we'll look at a few examples to ease us into what we'll start looking at. To begin, is 3 less than 2 true or false? 3 isn't less than 2, so it would be false. Turn it the other way and say, is 3 greater than 2? And that expression would be true. So next example, if integer x equals 3, then x equals 3, true or false? That would be true. So basically the operator, which is a single equal sign, is used for assignment, and a double equal sign is used for evaluation. In other words, a single equal sign is used for telling, so I'm telling x to store the value 3, and double equal sign is used for asking. I'm asking whether or not the value of x equals 3. So last example, given that x is equal to 4, is x not equal to 3? True or false? So that would be true. Now here the exclamation mark and equal sign together mean not equals. So then the answer is true, 4 is not equal to 3. So there we just learnt about some new operators which can be used to evaluate an expression, and this means this will lead us smoothly into the next tutorial. So, hope you understood everything we discussed today, and until the next time, take care and see you. Bye bye.